Можемо самим.
So do you remember your trig functions, guys? Last time we spoke about radian and degree measure, and I wanted you to realize that radian measure is the natural thing. It is something that you think about when on a nice sunny day you're driving in your car and listening to this song. Do you know the song on the radio? So why is that, guys? So can you you see your car is driving and you see your speedometer, right? So I don't hear on the radio, I personally hear the radian, right? So as the wheel is turning, the distance that you actually observe, the rotation is converted to linear distance, because the angle here, it is the angle, guys. If you are opening an arc of radius theta, the radius theta is part of the crust of the pizza. Okay, that's where you are seeing the theta, right over here. And that's so then we can define the following trigonometric functions. I can define cosine of theta, sine of theta, and tangent theta. So you can see all of them in this picture. Okay, so when I roll the angle in the positive direction, that means the rotation is counterclockwise. That means that the expansion is happening right over here. Yes, and the radius, it's going to be always, we're going to measure it as 1 unit radius. Okay, so whatever the circle, the 1 here, it's a unit circle that we consider because 1 is the 1 unit of radius length. And so as I open up the arc, I will see several things. I will see that I can form a right triangle. The vertical segment, I imagine what I do, I imagine I open up a crane, and the vertical segment is what I call sine of theta. Anyone here? Mute yourself, guys. So you see again, so we are opening this this angle. That is going to be angle theta. The vertical segment is then going to be, I call it the rope from the crane. It's going to be of length sine theta, which will also indicate to be positive if this rope is measured against the positive y-axis. Similarly, there is this shadow from the crane, and we call it cosine of theta. Theta is here. Let me show you some animations that I made. Here is an animation for sine. If you watched the cartoon, you realize why I make that sound. So I imagine that what's happening is that I open up the crane. Now I drew the angle over here. You see, I drew that the angle is over here. Actually, the way the angle is measured, so where is this 0.87? This 0.87 is this arc here. It's this slice of the crust measured in terms of the radius. It means that this segment is 87% the length of the radius. And as you can see that as I am increasing the angle, as I'm opening the arc wider, the red rope is getting longer. And the green shadow here is getting shorter. You can see, right? So very simple angles for sine. I mean, how do I calculate sine? Sine of 0 is 0, because at 0, the rope is essentially invisible. Here it's almost invisible, you can see, right? And the shadow is longest. As I open it up, you see here, the sine is equal to 1. Why is it equal to 1? because it was equal to 1 because the rope became the length of the crane. Notice what's happening over here. Here the rope is again decreasing, reaching 0 when theta is approaching 3.14 or 3 or basically pi. Here it is already below the x-axis, and you can see that that means that our crane is underneath water, which means its shadow is on the negative y-axis. That's why sine is negative. So what happens, the rotation is marked as follows. It is first quadrant, second quadrant, third quadrant, fourth quadrant. So let's check a few things. Guys, what are the where is sine positive? Could you tell me please in the comments where sine is positive? Let's see if you follow. Which quadrants correspond to sine being positive? Okay, 1 and 2 only. Thank you. Thank you, guys. Good, good. You understand? So what is the sine thing? It is just a geometric function. Open up an angle. In other words, we are considering radian measure. So open up the arc wide enough. Here it is. Here is the theta. And sine will be just the length of this vertical piece of rope. I imagine a crane coming up. So I imagine the crane dropping down its buoy onto the water. And this rope has a certain length in terms of radius units. Would anybody tell me what's the very biggest value sine can be? And of course, why? So what is the biggest positive value sine can be and why? Okay, 2 people replied, yes. 3. Come on, you can do it. 1. Right now you said 1, but more interesting to me is why. Could anybody tell me why the biggest value sine can be is 1? Yes, but why? Why is 1, guys? Not because you memorized it, so visually obvious. Why can sine equal to 5, for example? And then there was silence. Positive on y, but positive 5 is positive. Why can sine exceed the number 1? You see the animation. Pythagoras Theorem, why? There are triangles that have sides longer than 1. Radius 1, that's already good, David. Guys, this is a rope that dropped onto the x-axis. We are always dealing with a unit circle because we are always measuring the radius as 1 radius. You understand? So you make a bigger circle, the units changed. It's just a different radius, but we are measuring angles in calculus in terms of radians. Do you understand, guys? It means that this piece, this is where you see the angle. Remember that the angle for degrees is drawn over here or something like that, right? But really, what is an angle? In degrees, it's just the number of slices out of the 360 Babylonian slices. Good? That's what degrees are. And that's not natural because you can cut the pizza into however many pieces you would like. Radian measure is a measurement that uses this property of the circle that the radius can be folded around the circumference about 6.28 times, right? About, well, exactly 2 pi times, which is about 6.28. Are you with me? Yes? And so what I do when I consider the trig functions, I measure the length of, you see, I produce a right triangle with this red leg and this green leg. You can think of this red leg as the length of the rope with which that connects the crane to the buoy, right? That's what I indicated in this animation. You see this big black dot? That's a buoy. It stays floating on the x-axis. And then I describe the position of this crane as follows, you see? I begin lifting the crane. You see, why sine 0 here? Because the crane lies flat on the water, and the length of rope connecting it to the ground is 0. You don't need to drop any rope to the buoy. Now, as I open, do you see what happens? As I open, I'm lifting the crane counterclockwise. Now the distance from the top of the crane to the buoy is growing. That's this rope here, this red rope. Yes? And what is its length? Its length never exceeds the length of the radius. Can you see that? When you say that sine cannot be more than 1, you're saying that the leg cannot be longer than the hypotenuse, because hypotenuse measures 1. This cannot be longer than that 1 hypotenuse. It's longest at what value? What's the value of the angle at which this sine is biggest? Could you tell me? When is that biggest? What's the corresponding angle? So sine is 0 when it's 0 radians. When is sine equal to 1? When will that be 1? You see, at the moment I paused, it's 0.69. It means that this arc is 69% the length of the radius. You understand? This is probability, actually. 0.69. It's a ratio. You can use it for all sorts of things. So it means that this arc is 69% the length of the radius. When will the arc, but when will this red line be longest? Its longest value will be 1, yes? When will that happen? What should be the angle? Here. I'm getting there. You see, I'm lifting and the red line is getting longer. What should be theta equal to for this to be equal to the biggest value it can, to 1? Come on, guys, you cannot be confused by that. How much do I climb? This is half a circle. How much do I climb? Did you lose consciousness? What's wrong with you guys? Do you understand the question? Can you hear me, guys? Or the connection got lost or something? You can hear me. When is sine equal to 0? Sine is this red lobe. When is it equal to 0? What's the angle? And then when is it equal to 1? Do you see what is 1, 2, 3, 4? Why is it 4? Those are quartiles of a circle, correct? So when is sine equal 0? When is it equal to 1? Oh, I think there was some problem. That's why I couldn't see it. Okay, so let's see again. Okay, so here it is. Let's see. Y-axis pi over 2, 90 degrees, pi over 2, 90 degrees. Guys, yes, 90 degrees is very good. Just think in terms of radians. What is 90 degrees in radians? What is a quarter of a circle when it's radians? Sine of 0 ping does not equal 1. At 0, sine is 0. At pi, sine is 0. And 1 is at pi over 2. Let's again see that in the animation. Look at it, guys. Look at the animation. Do you see that? How do I know it's 0? It's very simple. I just visualize where the crane is. When the angle is 0, the arc is 0. The crane lies flat on the x-axis. Good? The crane lies flat on the x-axis. Now, when I begin increasing the angle, so this here is the angle. It's this part. When I begin increasing the angle, the length of the rope gets larger, reaching its largest value at 1/4 of the circle. Here, right? That's when sine is 1. It's 1/4 of the circle. Then it begins to decline. Sine begins to decline, reaching 0 again. When what? When the crane lies flat on the x-axis, on the negative x-axis. This time, that's an arc. Here it is. You see, this is really this arc. Doesn't matter if you draw a small circle or a large circle. The arc is actually here. It's pi radians. This is pi radians. Sine of pi is 0. Sine of pi over 2 is 1. Good. God damn it! I'm having some. I'm not sure what this. It's glitching. So let me do another screen share. Good. Yeah. Good. Let's see what else. So yes. By the way, you haven't been hearing the sound. I noticed. So this is why I asked you to watch the cartoon. It is associated in my head with construction. One thing I wanted to ask you guys is this. Now, sine is negative in third and fourth quadrant because now it's underwater, and this rope, its length is measured against the y-axis. Yes. So far, so clear, right? It's the radius. So again, sine is this function where the exact calculation of what happens to the angle and how it's converted to the length of this red rope is not immediately clear to us. But it's clear that if I open up the angle to some value, some radian value, there will be a corresponding length of rope, which I can then interpret in terms of how long it is on the scale of 1 radius. Now, cosine. Let's talk a little bit about cosine. It's this horizontal shadow. I also have animation for it. But tell me, when is cosine equal to 1? When is cosine equal to 1? Zero degrees and 0 radians, guys. Think in radians. Degrees do not convert. When you're riding in your car, the wheel is turning. The number of turns of the wheel converts to distance traveled very easily when you use radians. Why? Because what you can do is you multiply by the length of the radius. You multiply the number of turns by the length of the radius, and that gives you the distance traveled. That works when you're using radian measure. The circumference of the wheel is 2 pi times r, right? So every time a wheel makes 1 full revolution, you have traveled roughly 3.14 times the distance or the length of the radius of your wheel, right? So if your wheel is, let's say, 1/4 of a meter, and then every time the wheel rotated, the linear distance that you traveled is the circumference of the wheel. It's 2 pi times 1/4 of a meter. Good. So when is cosine equal to 0? Pi over 2 and what other value? And 3 pi over 2. Very good. We look at it. What is pi over 2? This is 1 pi over 2. This is 2 pi over 2. And this is 3 pi over 2. Can you see where I am, right? You travel 3/4 of a circle. When you're here, cosine is 0 again. Yes? So it's 1 pi over 2, 2 pi over 2, 3 pi over 2. And 4 pi over 2, it's 2 pi again. You're back in the original. Cosine is clearly only positive in which quadrants? Cosine is positive in which of the quadrants? You see, you label them as you rotate counterclockwise. Which quadrants correspond to sine being, sorry, for cosine being positive? One and four. Yes, 1 and 4. Because when you're in quadrant 1 and 4, the green shadow is on the x-axis. Good? All right, so this is just discussing the value. So for example, when I say sine of theta equals to something like 0.9, what is that 0.9? 0.9 of what? Not of the crust. Well, the crust, if you say the crust is one length of what exactly? 0.9 of the hypotenuse, yes, Lakey. In particular, 0.9 of the length of one radius. Understand? So the values of sine that you get are proportions. How much of the radius is that length? So you measure in radius units. You understand, guys? It's much more convenient. You measure both angle and this length in radius units. Okay? The arc is measured in radius units. The length is measured of radius units. Now here in this picture, you also see tangent. Tangent is what? It's defined to be also it's the slope of this line line from here to the dotted point, and it is the ratio of sine over cosine. It's the ratio of the two legs, vertical leg divided by horizontal leg. Here it is in the picture. How do I know that it's over here, guys? Very simple. Okay, so look at it, right? I can expand this triangle without affecting this ratio. You see the ratio of red to green is tangent. You understand? If I make the green longer, I can make the red proportionately longer. Do you see that the two triangles, the one that continues with dashed hypotenuse and the one with red and green, are similar triangles? Do you agree? You see in the picture? Why is this tangent? It's going to be important later on. Yes? The triangles that are marked with red and green, and the triangle that's marked by the black hypotenuse continued by the dashed hypotenuse, are similar triangles. They have the same angle here, right? The same opening. I just extend the radius further. Now, when I extend the radius farther, if I extend the horizontal length to be of 1 unit, now the tangent is simply the vertical segment. You understand how I did it? I just extend it. I extend this triangle until the horizontal segment is 1 unit length. The vertical segment therefore had to also increase. So this purple, or whatever color that is now the tangent. Do you understand? Look at the picture. Do you understand before I move on? Let me know. Again, do you see what I'm talking about? Tangent is defined as the ratio of red to green, of vertical to horizontal. Now, that means that if I scale this is a ratio, a proportion, right? It means, let's say this, let's say when tangent equal to 1/2, it means that the red segment is half the length of the green segment. You understand? So it's a rise over run. Red over green is tangent. You understand? Rise over run is tangent. It's the slope of this line, and it is a proportion of the triangle. So when I say red to green is 1/2, tangent is 1/2, that means that I can scale it up or down. I will see a similar triangle. Remember what similarity is, guys. You see, if you want to scale and make a copy, a statue of me to be smaller or larger, you definitely have to keep this ratio. For example, that the length of my index finger, let's say, is the same as the length of the nose. That should always remain true. That's what we understand as proportion. You understand, guys? When I say proportion, look at it. The two fingers are of the same length. This index finger is the same length as, let's say, my nose, for simplicity, right? So that means if you make a larger version of me or a smaller version of me, the proportions will stay the same. So this length divided by this length is 1. Similarly, for a triangle, there are fewer proportions than in a face, right? So the red to green, the vertical to horizontal must be of a particular proportion. That proportion is called tangent theta. So I can scale this triangle and make it larger. And then you see this triangle that I'm circling. Yes, this triangle has longer horizontal segment and therefore would have a longer vertical segment. But the ratio stays the same if they're similar. You see, it's the same ratio because it's the same angle here. It's a triangle that has the same shape. Good. So the purple to 1, this divided by 1 because it's now 1 unit radius. You understand? I expanded the horizontal to be of 1 unit length. Then the vertical expanded accordingly. So vertical to horizontal is now just simply vertical because it's vertical over 1. Are you with me? Please confirm if you understand what I'm talking about. That's important, right? So you all understand that this is tangent. Now, could you tell me what happens to tangent? So first of all, what happens if I begin increasing the angle? Great. If I increase this angle and approach pi over 2 from the left or whatever, And because this is approaching from the left, right? I'm going in the positive direction, right? So I'm approaching the second quadrant. I'm here, and then I'm here, and then I'm here. What's happening to tangent? What is the value of tangent approaching? Positive infinity, like, yes. Do you all see that? Positive infinity, because the red segment is getting longer, the green segment is getting shorter, they're all positive, yes? So it's like +1 over 0 plus. Remember, 0 plus means slightly more than 0. So this is slightly more than 0. It's near 0 plus, and this length is then also going to grow, right? This over that is going to go to infinity. What happens if I do the same, but I go into the second quadrant and I go back towards pi over 2? What's going to happen to tangent? If I'm in the second quadrant and I'm approaching pi over 2 from the right, in other words, I go like this, what will happen to tangent? Very good, Lakey. And the rest of you guys, there are 30 people here. So Lakey sees that. What about the rest of you? Tangent in the second quadrant is negative. You see, because we have cosine negative and sine positive, yes? Sine over cosine in the second quadrant will be a negative quantity. And cosine will be close to 0. So it will be +1, essentially, divided by something smaller than 0, 0 minus, yes? That will be minus infinity. Good. Now, similarly, in the third quadrant, tangent is negative or positive? Third quadrant, no. Is tangent negative or positive? Yes, great. Tangent will be positive in the third quadrant. You understand why? Because we have both sine and cosine are negative. You all see that? Both sine is negative and cosine is negative. When we take a ratio of two negatives, we get a positive. And what about the fourth quadrant? In the fourth quadrant, will tangent be negative or positive? Fourth quadrant, no. Very nice. It's negative because what? Cosine is positive, but sine is negative, yes? Now, for which values is tangent undefined? For which values between 0 to 2 pi is tangent not defined? Clearly, that's when the horizontal is 0, right? When this segment is 0. When will that happen? It's defined on the x-axis, right? But when it's not defined, it's when the horizontal is 0. When is the horizontal 0? If when I move to a quarter of the circle or 3/4 of the circle. That's 1/4, 2/4, 3/4. Yes. So that would be what is 1/4 of the circle? The full circle is 2 pi, right? Half a circle is pi. A quarter of the circle is pi over 2. Make sense? So tangent of pi over 2. I have 1 divided by 0 because cosine is 0, yes, undefined. But as I approach this value, I get plus infinity. Similarly, if I go to this value here, that would be -1. The red one is going to be of length -1 divided by 0, which is again undefined, yes? And you can know if it's positive infinity or minus infinity as you approach this value. You see, for example, if I approach 3 pi over 2 from the left, because here 3 pi over 2, that means I'm always slightly less than 3 pi over 2. What's going to be the value of tangent that I get? You understand? I take the limit. So I move like this. I move my radius like this. That means moving towards 3 pi over 2 from the left. What's going to be the value of tangent? What is it approaching? From the left, yes, guys? From the left. What's the value of tangent approaching? Write in the comments. Okay, one person replied. What about the rest of you guys? 30 students. I need more responses. What is that? You understand? Think about it, guys. What do we have here? The sine is approaching -1. Cosine is approaching what? Cosine is approaching 0. 0 minus, because cosine is also negative, right? So it is -1 divided by 0 minuses, in essence, right? Which means -1 divided by a tiny negative number, which makes it what? Positive, Stephen, that's right. In particular, it makes it positive infinity. Do you all see that, guys? So easy visualization, right? Just you see that. Good. So you understand that there is never any need to memorize those functions. It's what they do. I call it a Taylor function, right? So when you're making measurements, and then it's like you know when you're making clothing, you make measurements so that the suit is going to be suitable for the particular person. So how do we calculate sine? As far as we know, let's say, what is sine of pi over 4? Pi over 4 is a half of a quarter, right? It's 1/8 of my circle, right? Pi over 4 is when I cut my pizza into 8 slices. You agree? Pi over 4 is the radian for pi over 4 is the length of the American crust in radius units. So then I ask myself, what is sine of pi over 4? All I do is I open up the crust to be of length pi over 4 radius, right? Slightly less than 1 radius. And I measure against, let's say, the y-axis in radius units, how long is the red rope. That's all I do. The reason I call it a function is because each particular angle will correspond to a particular length of rope. Good? Now, of course, I want you to notice this, guys. Sine of theta is not, as many people will, even after this explanation, continue writing. It's not sine multiplied by theta, right? It is a sin to say that it's sine multiplied by theta. It's a sin of not understanding. This is not a number. This is just an expression. It's like saying Arkady of theta. It's just the name of the function. Say, make Arkady calculate what's the corresponding ratio of theta. Yes? And a very important question, extremely important, is naturally, can I come up with an explicit formula that translates theta into the radian length? Yes? So can I feed, let's say, pi over 4 and figure out what is the value of sine? Your calculator, you press in the calculator either degrees or radians. When you press it into sine, it spits out actual numbers. How does it do it? So what we're interested in figuring out is this. Can sine of theta be explicitly described using plus, multiplication, and division? In particular, we want to know whether or not it's a polynomial of theta. Do you remember what we did for e to the x? I hope you understood that, right? That's very kind of nice idea. So can we do the same thing for sine? You have enough or soon you will have enough to figure out how to approach this problem. You see, can I figure out what sine of theta equal? What is it doing to the theta in terms of multiplication, addition, and things like that? Is it a polynomial? Good. So then here are some important trigonometric properties, guys. So this is, you see, when I say sine of minus theta, that means I'm opening my arc clockwise, theta units clockwise, right? So sine of minus theta, it's a code to open the arc clockwise. And you notice the symmetries. Sine of theta and sine of minus theta relate as follows, right? If theta is opened in the positive sense, then sine of theta will be the upper part, and sine of minus theta is the lower part. You're with me, guys? Upper part, lower part. Yes? And notice that they are always negatives of one another. One is the negative of the other, right? Sine of minus theta is minus sine of theta. I notice it geometrically here. Do you see that? Here is sine of theta, here is sine of minus theta. I just opened up the arc below, and it happened that if one is on the positive y-axis, the other is measured on the negative y-axis. They are of the same length. Yes? What about cosine of minus theta? How does it relate to cosine of theta, please? You understood my question, guys? I'm asking, you see there is cosine here, right? If I have cosine of theta as opposed to cosine of minus theta, what's the relationship between them? We understood, I hope, right? Did you understand, guys, that sine of minus theta is minus sine of theta? This is just a statement that if I open, let's say, counterclockwise the angle theta, and I compare it to opening it clockwise, I will see that I get same length of red rope, except that one of the pieces is below the x-axis. Let's say in this case it's this piece, and the other is above the x-axis. So one is negative, one is positive. That's why sine of minus theta is minus sine theta. Does it make sense? And if it makes sense, could you please tell me what is the other situation? What about cosine? Cosine of theta relating to, I'm asking this, guys, what about cosine of minus theta? What is this in terms of cosine theta? Remains the same. Yeah, so that remains the same. You can see that here. Open the angle counterclockwise or clockwise, you are left with the same shadow. You understand? What about tangent? Tangent of theta against tangent of minus theta. What's the relationship between those two? Okay, Yuzu, good, but I want to hear more people, right? I hear 2 or 3 people, and this is supposedly a review, guys. You see what I mean, right? So this is when a person takes this class, it's supposed to be cold, like you know it very well. But we'll try to correct for it. So More people I want to hear from. What's the relationship, guys? Tangent of theta and tangent minus theta. Think about it. Tangent is sine over cosine. Exactly. Tangent is with a minus, guys, right? Why do I get the minus? Is because it's sine of minus theta, which becomes minus sine theta, divided by cosine of minus theta, which just becomes cosine of theta. So we get the extra minus. And it's also, you understand, it's also switching slope, you understand? So tangent, you can see here is this, this slope is rise is positive, run is positive. Here run is positive, but rise is negative. So you can see that tangent is an odd function. This is called odd function. Okay, now another important thing is there is a relationship between the angle and the x and y coordinate system. I can convert it, okay? So what's the coordinate of this point in terms of the angle theta? You see, the angle theta is drawn over here, but that's a mistake. The angle actually is the circumference in radius units, you understand? So if I make the, now here, I don't consider it a unit circle because I want to relate the position of this point in terms of the units on the x-axis, right? The radius does not have to match the unit on the x-axis, right? So in that case, if we are using another scale, this is a length of a radius. This theta means we have theta radii, right? Theta radii, which means theta times r will be the converted length in terms of the units of this coordinate system. Yes? You follow what I'm saying, guys? Yes? So when I measure radian measure, it's just I always consider that my units are the same length as the radius, but sometimes that's not convenient. Sometimes the x and y axis are not given in terms of the unit radius, right? So for example, when you're driving your car, that's the important part here. When you're driving your car, you measure the radius, let's say in meters, right? So maybe the radius of your wheel is a quarter of a meter, let's say, right? Maybe less, I don't know how much it is, right? But some fraction of a meter, right? So one radius is equal to 1/4 of a meter. Then the corresponding arc, I can measure its length in terms of radius and then convert it in terms of the meters, okay? So let's say the full arc of that wheel, if the wheel has radius 1/4 meter long, the circumference of this wheel is going to be 2 pi times 1/4 of a meter, because it's 2 pi times the length of one radius, yes? And that's the length of the circumference in meters. So here is what I can say. Look at it, guys. The shadow here, look at it, it's a triangle. This is x distance and this is y distance, yes? And what do we know? We know that that cosine is the distance of x divided by r. You understand? It's x divided by r. It's a fraction, right? How much of it in terms? How many times does x fit into r? We have x divided by r. Why do we, again, or better said this way? Okay, we want to measure x, and to convert it to cosine, I want to measure x in terms of how many units of radius fit inside of x, right? So what do? I take x divided by r, because one radius is our units. Are you with me? Let's just make sure that you are. Let's do this easy exercise. Okay, guys, are you ready? I want to know the following information, right? So suppose that I have a circle, and it happens that the radius is 4 meters. Yes, radius is 4 meters, and then you were able to, you look at it and you found this, right? This you measured and you found this to be 2 meters. Yes, this is 2 meters. What is, so what is, so this is the angle theta here. What is sine of theta and y? So sine of theta is equal to what particular value? And y? When I answer this question, I mean, I have this angle, whatever that angle is. What do? I open it up, and then what do I want to do with this length? Yeah, but you say opposite over hypotenuse, perhaps, but really, you see, we can do it another way of thinking of it, right? We want to look at this red rope and do what? We want to measure it in unit radius. You understand? When I do trig, I'm using radians. In the sense, I'm measuring the length of this line segment in terms of radius. So I'm asking really, when I ask what is sine of theta, I'm asking how much is this in radius. You see? So we know that for meters it's 1 radius, right? So that means that what we have is that 1 meter equal to 1 divided by 4 radius, right? So therefore basically 2 meters is 2 divided by 4. You see why we divide by the hypotenuse? Because we are converting the measurement in terms of radius units, right? So the answer is that sine of theta equal to 1/2. You understand? You're dividing by, you're saying sine is opposite divided by hypotenuse. In essence, what you can think of is that what you are trying to do is when you divide by the hypotenuse, by the length of the hypotenuse, you are converting the length of the opposite in terms of hypotenuse lengths. How many hypotenuses fit in it? So the hypotenuse can always be imagined as the radius. Okay? Making sense, guys? You understand what I'm saying? In other words, when I say sine of theta is 1/2, I'm saying that this segment that it was measured in different units, when I convert to measuring in terms of radius, it measures half a radius. Right? That's why it's opposite divided by hypotenuse. It's opposite measured by the number of times hypotenuse is able to fit in it. Good? So then here in general, what's the measurement of x in terms of radius units, right? When I measure x in terms of radius units, I have cosine. Cosine that's exactly what it's doing. It's just measuring x in terms of radius units. It's that conversion. So if it measures x, then all I have to do is divide it by r, divided by the length of a radius, and I'll see how many times the radius fits into x. And that will be cosine, right? So x is some fraction of a radius, it's smaller, right? So it's going to be some segment, some proportion of radius. It's x over r, it's cosine, and y over r is sine. You understand? So by doing that, by dividing each of them by r, I convert them in radius units. Okay, and that means what? That implies that if I know cosine of the angle and sine of the angle, I can also figure out where this point is located. All I have to do, x is simply r times cosine. I just convert it back. It's r multiplied by the cosine value, and y is r multiplied by sine value. Do you follow? I hope it makes sense. It's pretty important. That's the entire essence of conversion here, right? It's just I talk about x and y in terms of different units, right? Here I might be measuring the x-axis in centimeters and the y-axis in centimeters, but if I want to measure it in radius units, I just divide by r. Each of the measurements I divide by the length of the hypotenuse in centimeters, right? And vice versa. If I know the length of x and the length of y in terms of radius units, I can convert it to the particular units that are used here. That's the x and y. It's just a matter of conversion. Good. Now, by Pythagoras theorem, cosine squared plus sine squared equal to 1. Remember, we proved the Pythagorean theorem. You have it available. It's pretty easy proof, yes? So why? Well, basically, we're saying that this length squared plus this length squared will be equal to 1. Why? Because measure this length in radius units, measure this length in radius units, measure the hypotenuses in radian units. The hypotenuse is then 1. The hypotenuse in radian units is 1. Good. So then this squared plus that squared equal to 1. Sum of the squares of the legs equals to 1. That's why we have cosine squared plus sine squared equal to 1. Very easy correlation. Yes, guys? Now, what we can do is next we can divide everything by cosine squared, and then we get 1 plus tangent squared equal to secant squared. Secant is 1 over cosine. That's secant, okay? Secant is, you see, how many proportions do you have? Secant, it's where you take this length. We want to find how many, so you take the 1 radius and divide it by the horizontal, by the horizontal leg, and all in radian units. You understand? So it's 1 divided by this length in radian units. And I can also do the same thing. I can divide by sine squared. Cosine over sine is cotangent. So you get cotangent squared plus 1 is equal to cosecant squared. So you already see where the Pythagorean identities are playing a role in trig identities. They are just restatements, okay? So then let's try to calculate a few angles. It's not easy to calculate all of them, but some angles are fairly simple. And I can always decide what I want to scale here, right? So you can read sine from any right triangle because you just convert the hypotenuse to 1, okay? So imagine that I want to know what is sine of 45 degrees. 45 degrees, it's pi over 4. You know what's 45 degrees? It's half of 90 degrees. So it's half of a quarter of a circle, 1/8 of a circle, yes? That's 45. That means 1/8 of a circle is 45. So that means 1 slice, right, guys? 1/8 of a circle, it's 1 regular American slice equals to 45 Babylonian slices. And the length of crust is pi divided by 4 of a regular slice. Make sense? So I want to know what is sine of a regular slice. So that means what I can do is, if I take this to be, I can begin with taking a square with side length 1. So this is 1 and this is 1, yes? And then I cut the angle in half. So you see, Alexa, you remember a few things, but try to remember as few things as possible. You don't try to memorize, you try to understand. You understand, let's say, it's in some sort of memory. You understand that radians measure the length of the crust of the pizza in terms of radius units. And degrees are just arbitrary slices. So you see why radians, I hope, are the more natural measure, right? Because they talk about, radian measure talks about the property of the circle. And conversion is fairly simple. Conversion is simple. I remember, you can remember that 360 Babylonian slices make a full pi, and a full pi has length 2 pi. Of the number of radii that you can fold around the circumference is 2 pi. That's the thing that you memorize, or you try to understand it deeper afterwards if you want, right? But we remember that circle is 2 pi r, which means circumference is 2 pi times the length of radius. Okay, So here I want to figure the exact value of sine, cosine, and every other thing of pi over 4. Now pi over 4 is half of pi over 2, which is 90 degrees. So I take this square. This angle here is a quarter of a circle, right? Which is pi over 4. And I slice it, and then I get pi over 4 as the angle. And I can consider this the sides to be 1 and 1. 1 squared plus 1 squared is square root of 2. So the hypotenuse is the square root of 2. If the horizontal segment is 1, the vertical segment is 1, then the hypotenuse is root 2. Now, then I can, when I ask what is sine of pi or pi over 4, it's the angle over hypotenuse. Or in other words, convert this measure into radian units. In radian units, I just simply have to divide by the length of the radius. So it's 1 over root 2, which is also, if I multiply by root 2 and root 2, it's root 2 over 2. I have another 10 minutes, I think. Yes, guys? Yes, makes sense? So you understand how I calculated root 2 over 2. I did not memorize any table. I just easily figured it out. Take a square, slice it in half, you get those angles. And then you know by Pythagorean theorem what's the hypotenuse. Once you know angles and hypotenuse, it's easy to calculate all the other values of trig function, right? So let's see if you understand. What is cosine of pi over 4? So please write, I would like you to answer it for A. Write cosine of pi over 4, tangent of pi over 4, secant, cosecant, cotangent, all of those functions. And if, guys, by some chance you're not good with trigonometry, stay after class, I will explain it. Don't leave it alone, right? It's very easy to understand. There is nothing so terribly complicated about trig. Please calculate cosine, tangent, secant, cosecant, cotangent at pi over 4. And let me know in the comments. Okay, Sumaya, that's nice. Come on. Thank you, Dragon. And calculate the others too. You have also cosecant and cotangent. Remember what is cotangent. Cotangent is the opposite of tangent. It's cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. Thank you, Jonathan. Cotangent, yes, thank you, Alexa. Good. Secant is square root of 2, thank you. Thank you. Very good. All right, so I'm hoping that you understood how this triangle was obtained, right? So you see, I cannot stand those mnemonics, SOHCAHTOA, and all this stuff. I do not understand why it's necessary. If you see the circle, you see what's happening. You see the sign of trig. You know, is it positive, negative, whatnot, and then the ratio. So let's understand for a moment, what about 3 pi over 4? How do I calculate sine of 3 pi over 4? Right, nothing so special. 3 pi over 4 means I go 1/4, 2/4, 3/4, right? Where do I end up? So 1/4, 2/4, right? 3/4, where am I? 2/4 means not quarters, apologies, eighths, right? 1/8, 2/8, and 3/8 of the circle, right? Pi over 2, remember, pi is half a circle, pi over 2 is a quarter of the circle. You see what I'm saying? Pi over 2 is a quarter of a circle. Pi over 4 is 1/2 of a quarter, so it's 1/8. So 3 pi over 4 means that I moved from 0 through 3 American slices. Yes? That's roughly what I tend to eat at breakfast, 3 American slices. So then what is cosine and sine and all the other functions at 3 pi over 4? So sine of 3 pi over 4 is what value, guys? Right. You see, guys, so I'm asking what is cosine, sine, all the 6 trig functions of 3 pi over 4. You can see them here. 3 pi over 4 is, look at it, here it's 2 pi over 4, yes? Now, it's roughly here, right? Because what I move is, this is 2 slices, right? This is pi over 2. 1 pi over 4, 2 pi over 4, 3 pi over 4. Yes? I move through 3 slices. What is cosine of 3 pi over 4? So notice cosine is negative. Aside from that, it's the same triangle as I had in the first quadrant. You understand? The way you can tell is, I imagine doing this. I imagine going all the way to pi. So 3 pi over 4 is pi minus pi over 4. So it's like walking all the way to here and then moving back. Yes? Then moving back. So it's like opening an angle. This is then pi over 4. It's like that same triangle I see in here. Same ratios, except it's in the second quadrant. So sine will be the same value as before. It's root 2 over 2. Cosine of 3 pi over 4 will just be the same, but with a negative sign, because we are on the negative x-axis. Am I making sense, guys? What will tangent be? Tangent will be what? So if you guys, you are, yes, great, Christian, thank you. If you're having any, if you're struggling with this, then stay with me. We can easily, I think, understand it. Imagine this, right? Just imagine where we are located, in which quadrant, and then imagine the ratio. So it's -1, right? Cotangent is also -1. Secant, what is secant in the second quadrant? So secant of 3 pi over 4, what is that? Quickly, guys. Secant of 3 pi over 4. minus square root of 2. Thank you, Christian. Right? So, guys, you understand how simple it is. Look at it. Everybody can construct the square and construct those ratios, right? So it's just the same triangle, but one of the legs is lying on the negative x-axis, another lying on the positive y-axis. So kind of like here, you see, negative x-axis, and this is measured against positive y-axis. So it's really the same triangle, just I consider this to be negative, the horizontal leg to be negative. Good. What happens at 5 pi over 4? Where is 5 pi over 4? What quadrant is 5 pi over 4? It's very simple, right? It's 4 pi over 4. 4 pi over 4, it's here. And 5 pi over 4 means rotate into quadrant 3. Right? Rotate 5 pi over 4 is 5 American slices. I'm here. Here the y and the x are both negative, right? So cosine will be negative, sine will be negative, tangent will be positive because it's negative over negative, right? But I can easily read, aside from that, all I need to know is the ratios of the triangle. What are the proportions of the triangle? So I just need to know the orientation of the triangle and its proportions, nothing more. Good? All right, so I hope that is helpful, guys. We do need to try to speed things up. I want you to understand trigonometry. It's very important for whatever follows. And if you actually bother to look into that book, remember I suggested quantum physics. You can see how those ideas come together. If you're interested in quantum physics, here is motivation for you. If you're interested in I can tell you in probability, there are so many amazing problems. I, for example, figured out just recently why only 38% of all your applications are ever looked at. It has to do with the number E, if you're interested, right? So you apply, you wrote something, maybe you had actually a stellar application, but the probability it will be looked at when you are interviewing for jobs is only 38%. Maybe they, of course, use other tools, but if it's actually manual checking, they are going to go like this. Okay, if it's that's called the secretary problem. I should send it to you. All right, guys. If you are not staying for office hours, I wish you farewell. If you are, and I do encourage you to do that, we can talk more about trig and anything else that you might be interested in. Take care if you're not staying.